Hello everyone. Hello future engineers. This video discusses about the principles on how to determine the member forces of a 2D truss or a plane truss. And I present two examples here. In my future videos, I will present more, especially the challenging ones. So if it is your first time in my YouTube channel, don't forget to subscribe and press the notification bell so that you will be updated of my future videos to be uploaded here in YouTube. So enjoy watching and good luck in your studies. So here we go. We have the first problem. This is about method of join. So determine all member forces and indicate if the member is in tension or compression. So we are given this simple truss, and first let's consider the entire system. And if we sum up forces horizontal, the horizontal reaction at A is 20 kilonewtons leftward. So let's denote the vertical component of reaction at A as AY and at G R sub C both upward. So let's sum up moments about point C equals 0, clockwise as positive. So we have AY times 15 plus 20 times 6, then minus 30 plus 40 combined because they have the same moment arms. So 70 times 7.5 equals 0. So solving for AY is equal to 27 kilonewtons upward. Likewise, summation moment about A equals 0, counterclockwise positive. So we have R sub C times 15, then minus 20 times 6, minus 70 times 7.5 equals 0. So R sub C is 43 kilonewtons upward. So if we perform checking, 27 plus 43 equals 70, the downward force. So let's consider joint A, but before that, let's solve for the angle that AD makes with the horizontal as well as AB. So tangent of theta AD is equal to 3 over 7.5. So theta AD, which is equal to theta CD, is equal to 21.8 degrees. Likewise, tangent of theta AB is equal to 6 over 7.5. Then theta AB equals theta CB or theta BC equals 38.66 degrees. Now we isolate joint A and we set up two equations of equilibrium, namely summation forces x0, then summation forces y equals 0. Of course, the principle is we always assume that each member is in tension, so that if the result is positive, then it's correct. But if the result is negative, then the member is in compression. So summation forces x equals 0, then we have FAD cosine of 21.8 plus FAB cosine of 38.66 minus 20 equals 0. So simplifying, FAD cosine 21.8 degrees plus FAB cosine 38.66 degrees equals 20. Call that equation 1. Summation forces y equals 0. And we have FAD sine of 21.8 degrees plus FAB sine of 38.66 degrees plus AY, which is 27, equals 0. So FAD sine 21.8 plus FAB sine 38.66 equals negative 27. Okay, from equation 1, let's express FAD in terms of FAB. So transpose FAB to the right, divide everything by cosine 21.8, then we have FAD equals 21.54 minus 0.841 of FAB. Let's substitute this into equation 2. So 21.54 minus 0.841 FAB sine 21.8 plus FAB sine 38.66 equals negative 27. So only FAB is left in this equation, and by your calculator, we solve FAB equals negative 112.04 kilonewtons. So that means FAB is 112.04 kilonewtons compression. Then substitute into the formula for FAB. FAB 21.54 minus 0.841 times negative of 112.04. So FAD is 115.77 kilonewtons. So it is tension. Then we move to joint C. Joint C, summation forces X equals 0, considering leftward as positive this time. So FCD cosine of, these are the drawing for the force as our guide. So FCD cosine of 21.8 plus FDC cosine 38.66 degrees, then equals 0. Then summation forces Y equals 0. Then we have FCD sine 21.8 plus FDC sine 38.66, then plus RC, which is 43, equals 0. So from equation 1, call it equation 4, from equation 3 rather, FCD is equal to negative 0.841 of FDC. Let's substitute it into equation 4. So substitute into equation 4, then we have negative 0.841 FDC times sine 21.8 plus FDC sine 38.66 plus 43 equals 0. So leaving FDC as the only unknown, so we can compute FDC using your calculator there. So FDC is negative 137.65 kilonewtons, or FDC is 137.65 kilonewtons compression. Then substitute the value of FCD, FDC into this equation here. So FCD is negative 0.841 times negative 137.65. So FCD is 115.76 kilonewtons tension. So we expect FCD to be equal to FAD, because if you sum up forces horizontal at joint D, there's no other force horizontally, so they are expected to be equal. So there's a very small discrepancy because of rounding of values, but that checks that our solution is correct. Then finally, at joint B, summation forces vertical equals 0, downward as positive. So we have FDD plus negative, this is FDC, negative 137, FAB, negative 112.04 sine of 38.66 plus negative 137.65 sine of 38.66, then minus 40 equals 0. Plus 40 rather equals 0, because downward is positive. So solving for FDD, the only unknown, so FDD is equal to 115.98 kilonewtons. So as a customary check, then you should sum up forces along X at joint B, then prove that it is almost 0 or simply 0. Then you can also perform arithmetic check at joint D, because we haven't yet isolated joint D, as a good practice in order to verify that all these our answers will be correct. So I'll leave that to you to check summation forces X at joint B, then prove that it is 0 or almost 0, then as well as at joint B, summation forces X must be 0 and summation forces Y at joint D must be 0. So that's it for this problem. So, second problem, by method of sections, determine the member forces of BC, BG, HG, CD, and CG also indicate if the member is in tension or compression. So this is the figure. So supposedly, you can combine method of sections and method of joints to analyze these required members. However, let's stick to the instruction that we should only apply method of sections. But in your practice, you can actually combine method of joints and method of sections to facilitate the analysis of the truss. So let's have this AY, then AX is 0 because there is no horizontal load, then R sub E. Considering the whole system, summation moment about E equals 0 clockwise as positive, and we have AY times 24 minus 80 times 6 minus 60 times 12 minus 50 times 18 equals 0. Solving for AY is 87.5 kilonewtons. Then we section BC, BG, and HG. All these are required in the problem by a vertical section. So call this section 1-1, and let's indicate the forces, the unknown forces. So FBC, FBG. By the way, the slope of FBC is 6 horizontal, 1.5 vertical. So 6 divided by 1.5 is 4. So we can reduce it to 4, 1 vertical, then square root of 17 for the hypotenuse. Then for BG, we have 6 and 4.5. We can reduce that to 4 horizontal, 3 vertical, then 5 hypotenuse. Then HG is horizontal. First, to solve for the force in member BC, we sum up moments about G so that BG and HG will meet at G and they are not involved in the equation. Then we use principle of transmissibility of a force by moving or sliding BC on its line of action at C. We transfer it at C. There are two components, horizontal and vertical. I will not show the vertical component because the vertical component passes through G. It has no moment. So only the horizontal component, which is FBC times 4 over square root of 17. So take note, AY is 87.5. So considering left of section 1-1, summation of moment about G equals 0, clockwise as positive. So FBC times 4 over square root of 17, the moment arm is 6. Then plus AY, which is 87.5 times 12. Then minus 50 times 6. Then no more, equals 0. So solving for FBC, FBC is expected negative because it is a top chord member in this situation here. So negative 128.85. So FBC is 128.85 kilonewtons compression. Then FBG, to solve for FBG, so that FBC and FHG are not involved, supposedly we locate a point of the intersections of the lines of action of FBC and FHG somewhere here. But there's another simple way. Is simply sum up forces vertical if we believe that FBC is really correct, and I believe in that. So you must believe, you must be confident with yourselves that you correctly compute FBC. So the simpler way is summation forces vertical, summation forces y equals 0. So we have AY 87.5 plus FBC, which is negative 128.85. The vertical component is multiplied by 1 over square root of 17. Then minus 50 equals 0. So minus FBC FBG times 3 over 5, the vertical component of FBG equals 0. So solving for FBG, FBG is 10.415. Since it is positive, it is tension. Then for FHG, we sum up moment about B equals 0, counterclockwise as positive. So FHG times 4.5. Then 50 has no moment. Then minus AY, 87.5 times 6 equals 0. So FHG is equal to 116.67 positive. So tension. Next, we check if these three forces, unknown forces, are in equilibrium together with the loads. So summation forces X equals FHG rightward plus negative 128.85 times 4 over square root of 17, the horizontal component of FBC, plus FBG times 4 over 5, 10.415 times 4 over 5, and the result is almost 0. So we are confident that all these answers are correct. Then we section CD, CG, BG, and HG. So call that section 2-2, and let's consider all forces to the left of section 2-2. So these are the cut sections. So to solve for FCD, since these three unknown forces, supposedly, although known, the two are already known, we sum up moment about G so that we can solve CD. Only the horizontal component of CD has moment about G. So summation moment about G equals 0, clockwise as positive. So we have FCD times 4 over square root of 17 times 6, then plus 87.5 times 12, then minus 50 times 6 equals 0, which is exactly the same as this equation here. So therefore FCD is equal to negative 128.85 as expected, because if you isolate joint G, summation forces horizontal, we can conclude that FBC equals FCD. So that's why FCD is also negative 128.85. Then having found FCD, so FCD is 128.85 compression, kilonewtons compression. Supposedly, we can compute FCG by method of joints at C by summing up forces vertical. But unless otherwise, you're free to do that, because I'm planning to solve this problem by purely method of sections. So only in other problems where there's no specific method that you are told to use or to do so. So we sum up moments, we sum up forces vertical in this case equals 0. So summation forces Y equals 0. We have 87.5 minus 50, then minus 10.415 FBG times 3 over 5, the component, vertical component, minus FCG minus the vertical component of CD, which is negative, so minus negative 128.85 times 1 over square root of 17 equals 0. So solving for FCG, FCG is equal to 62.5 kilonewtons. So it is positive, so it is tension. So that's it. And I hope that you easily follow the solution. You just watch it again, the video, if you want to understand it further.